Welcome to another 3D printer review video. This is a Centauri Carbon by Elegoo. And Elegoo especially asked me to compare it with Bambu X1 Carbon. This is also a fast CoreXY printer with similar properties like with the X1 Carbon. The build volume is also same, 256 mm in X, Y and Z direction. Now we have huge difference in price. This should be approximately around $500 versus $1,200 of X1 Carbon, of course depend of the country. The maximum temperature of the hot end is 320 degrees Celsius on this one versus 300 on X1 Carbon, and this one has a 60 watt heater versus 40 watt on the X1 Carbon. So this looks like a good printer for the technical filaments too, because it is equipped with bimetal hardened steel nozzle with a hardness of 60 Rockwells. And the bed temperature is 110 degrees Celsius. I believe that in US and in Europe too, because X1 Carbon in Europe the limitation is 110, but in US I think the max temperature is 120 degrees Celsius. 500 millimeters per second is the max speed and 20 meters per square seconds is the max acceleration. This is similar on both printers. And this one have a 2.3-inch touchscreen. It has air filter, camera, but it don't have the LiDAR sensor. But let's see what's in the box. In a box, user manual, power cable, spool holder, screen, some tools, and this is sample filament. Maybe it's enough for the Benchy, but you know my opinion about this. Maybe it's better if it's not included at all. Between tools we have Allen keys and some screwdrivers too. But unfortunately flash cutters and tweezers are not included. This is my own. It's very important to remove these three securing bolts for the transportation. They're marked with these red arrows. The plate is two-sided. This is side A with bigger texture for PLA, TPU, ABS, PETG, carbon fiber. But which carbon fiber? Anyway, side B, it is optimized for the PLA and it has finer texture. Can I use Bambu Lab sheet? I'm curious, because I can see here it is a little bit wider, but the total dimensions are slightly smaller, maybe 1 or 2 millimeters. I can see a slightly bigger gap, but I think it should work anyway. Let's continue with the assembly by connecting the screen. Nice. A warning, connect to the internet and update the firmware before the use. Let's take a closer look. So we have the screen and next to it is a USB port. And from inside I can see the Z stepper motor. Probably these three lead screws are connected with some timing belt. The linear rods on X and Y are from metal. The camera is in this corner and below it is the LED light. We have two bigger stepper motors here on the back side. These are for the CoreXY moving mechanism. And this is space for the purge material with some cleaner from the silicone, I think. Some kind of silicone brush. By the way, this is the maximum opening angle for the doors, and I know that many users will not like it. We have a sealing tape on three sides and it is extremely good. But on fourth side I can see a 2 mm gap, but I think it's completely acceptable. And this is the exhaust fan with the filter inside. And this is the back side, and I find it a little bit weird that the timing belts are in front of it. So this is the back side of the printer. We have the opening for the purge material, and can you notice one important thing what is missing here? Yes, a spool holder. It is on the side now, and this is the filament runout sensor. Let's turn it on and the device should do the self-check. Choosing the language, confirming that securing bolts are removed, and then it asks me that a plate should be placed inside with the side A up. Oh, this self-check will take 30 minutes. Okay. It's doing the input shaping, vibration compensation. I'm not sure which fan is tested now, but I can feel that airflow. Maybe you can see it on this paper. And the last step in this self-check is the auto leveling. It would be easier for the waiting if we could see here some countdown time or measure point or something like that. Wow, this is one of the slowest auto leveling I ever experienced. It's running more than 20 minutes and it's not even finished yet. Wow, self-check completed in more than half hour. Next step would be heating up the nozzle and start with the first print, but I forgot to mention that I have to insert the filament first. It's connected to the internet. Unfortunately, it didn't work with 5 GHz network, only with 2.4. And using that IP address, I can connect to the printer over the smartphone or over the laptop. I can see there is a newer version now. Let's do the update. The firmware is updated in less than 2 minutes together with the downloading. Now I can see they can still do some fine tuning. For example, I cannot read the end of this text. There is no scroll. The LED is not too strong. Just really minimally helps to see something on a camera. I think this will be one of the first updates by community. Let's see what printing we have on this USB drive. 15-minute Benchy. Let's heat up the nozzle. And insert this sample filament. I needed 5 minutes to untangle this, and for the Benchy I need 4 meters. I'm not sure if this is enough. Filament is inserted, but it poops on the backside, so it needs some poop sheet. I'm curious, after printing request, when will actually start with the printing? Maybe this will be a 15-minute Benchy, but 9 minutes is used for the preparation. I like with this extruder that actually we can see the nozzle. The noise from half-meter distance. And with the doors closed, approximately 55 decibels, but of course for PLA we need this opened. The progress is good. I hope this will be enough. Okay, immediately bed adhesion check. Okay, it's good. It's very good. I have to wait until it cools down. The bed cooled down. Perfect. The white color is good to hide the imperfections, but basically this is not bad Benchy. I can see the hull line and maybe just one string, but otherwise I cannot see other issues with this object. This is Elegoo slicer, which is based on Orca slicer, and this calibration cube D6 dice will be the first object. I slice it and I save the G-code to my computer, which later I uploaded over the user interface. Later I will try to enter the IP address and start the printing directly from the slicer. And hopefully with this printing I can check the filament runout sensor. Sensor is triggered, but it didn't stop so far. And I double check the filament detector is enabled. Okay, let's try to do it manually. Pause the print. Theoretically it should load the new filament, but it's stuck at this step. It is heating up the nozzle, but it reached that temperature. There are two important things I want to mention now because I learned that later. First of all, the printing will not stop immediately after it runs from the filament here, but only when this end of the filament will be somewhere in the extruder. And then it will stop and you can replace the filament. Almost you can push the next one. But there is one bigger problem. This is the second thing I want to mention. This Teflon tube is quite tight and maybe inside this bending it's even broken, because when I was pushing new filament I feel that I hit the end, but actually it was somewhere here and not inside the extruder. So maybe it is somewhere broken inside, but it doesn't have to be so tight, and it's not so easy to replace it because we are limited with outer diameter, but it will be good to have some bigger inner diameter of this Teflon tube. It's not necessary to be tight. And looks like this time it will be finished correctly, but of course I have enough filaments for this. The dice looks really nice. This is the top layer, bottom layer, and also the side surfaces. There is no sign of the ghosting or similar. With next printing I want to test the bed leveling, and I prepared these flat objects and I try to upload it directly using the IP address, and unfortunately I cannot do it from some reason. I get this error. So I saved the G-code to my computer and I uploaded it over the user interface. But you will see next day this function will work without any change from my side. It will be one layer printing, the whole bed almost, and I'm starting with the bed leveling of course. The start is really good. And it's finished. Almost like piece of paper. Only at these two spots I can see some imperfection. The hour, and this will be 2.5 hours printing. Oh, this was surprising. I had a filament break and it detected now. And it's waiting for me to replace it. And this time it worked correctly, and actually here I learned that after triggering the sensor, the printing will be stopped much later. And here I faced that second problem I mentioned, that the filament stuck inside this saffron tube somewhere near the end, so definitely some bigger inner diameter tube would be better. It's in now finally. Completed. This will be a success this time. Okay. And this is what can I see over this user interface, and later I will show you the time-lapse how it looks like. It finished the hour correctly, and it is completely in standby position. There is no any kind of the noise. It looks really nice, no issues with it, and somewhere here it was the filament run out, but I cannot really see exactly where, so the change was successful. If I want to see the time-lapse, first I have to export it to a USB drive, and later I can copy it to my computer, and this is the time-lapse. Not the best quality camera, but for checking the printing, for that it's enough. One more time I tried the filament runout sensor, so when it is triggered, after approximately half minutes it will stop the printing, so this part works correctly. But the unload and load functions, not really. Here I was waiting even 5 minutes to see what happens because it showed that it reached the temperature, but nothing happened. Only manually when I set the temperature and I extrude and unextrude the filament, I changed it successfully. But new users don't really know what to do here. The quality of the printing is great, so no complaints here. This figure was also on that USB drive. And now let's try some technical filament. This is Polymaker's ABS filament, which requires the enclosure. But again I have the problem with automatic unloading. Only when I set the temperature manually and unextrude the filament, I was able to change it. Slicer setting for the ABS, 260 on the nozzle and 110 will be the set bed temperature. This is the battery holder, very common gift time giveaway. Only I don't like to print this from the PLA. If somebody will use it with the charged battery, it may be too hot for the PLA. I want to measure the enclosure temperature, that is the sensor. I'm using this gap on the left side of the doors, and I will measure the temperature on this position. It definitely needs a stronger light inside, and maybe a transparent door would be better. Only now I noticed that I set bed temperature to 110 degrees Celsius, but it is printing on 90. After half hour the temperature inside is almost 50 degrees Celsius, which is good for the ABS. Printing is finished a few seconds ago. Bed adhesion check. It's good, but we have to discuss this brim. But I will wait until it cools down. Now look at this brim. This is a typical example where the nozzle is too low, and I saw this earlier when the probing is done on a cold bed and the printing is on high temperature, and it doesn't compensate this difference. This brim was a little bit hard to remove, but beside that this is really nice printing, nice overhangs, surface quality. To clean this brim I am printing a 1 mm thick shape. And I set the bed temperature to 110 degrees Celsius. I am starting the printing directly from the slicer. This first layer is too low, and again it's printing on 90 degrees Celsius instead of set 110. It's clean now. I have really mixed feelings about this printer. On one side I really appreciated that they created a budget-friendly printer, which is ready for technical filaments. I mean, printing above 300 degrees Celsius, that's more and more important nowadays, especially with some special technical filaments. But this is not really copy-paste of Bamboo printer, X1 Carbon especially, or maybe like in Excel, you know, we have that copy-paste when we drop out some functions. But something like this we have here. On the other side, it is more or less okay. I don't like the Teflon tube, it is quite tight, and also it has quite big bending at the end. And this glass is too dark. If I close it, then I cannot really see what's inside. Maybe some better, stronger LED light would be better here. But on the software side, it really needs improvement. I mean, I will not repeat all those things I mentioned during the video, but for example, basic things like load-unload function must work perfectly, because beginner users will use this and he will be confused that it's not working properly. Okay, I know that it will be improved by maybe further update or something like that, but it should work already now. If I set the bed temperature to 110 degrees Celsius, then why is it printing on 90 degrees Celsius? And these kind of things are really confusing. Do I recommend this printer? Well, if you are ready for the tinkering, then yes, definitely, because it is really prepared for those technical materials. But maybe a tinkerer would appreciate better some open source clipper, because here, I don't know, I cannot change even the printer configuration file to, I don't know, reduce the heating of the frame with that sensorless homing or something like that. So as I mentioned, I really have mixed feelings about this, and I know that there will be at least 20 videos on the same day published because we have this embargo. And if this printer is for technical filaments, especially for those which requires higher bed temperature, that first layer definitely must be fixed, because you saw my results with this ABS printing. Probably the reason for this is the probing on lower temperature and the printing on higher temperature. So all this must be compensated, or maybe do this probing on the preheated bed temperature. My friend Everson from Geek Detour, he will try to investigate if it is ready for the AMS units as a future upgrade, because currently, of course, we don't have this option. And I don't know, so this is my first experience with this printer. Thank you for watching this video, and I wish you happy printing.